here we go. So finally, I promised a video series of 6 and I've done 1. Yeah, this is an interrupt from the main narrative anyway to talk about stack reordering because everybody's having problems with this and there's a solution. Right, so we're 1337, but you know what, it doesn't really matter what version of DNAC you're running. The principles are still the same. So what is going on here? How we are dealing with the stacks. What is it about the stacks we're dealing with? Well, actually, where are we on our workflow? So we did a video on LAN automation already. Thank you for those who watched that one. This is where we are now. We've kind of gone off the main narrative to do stack ordering and how we deal with that. These videos will come in due course. We're kind of off-piste. So assume knowledge, you know what is stacking. We combine multiple physical switches into one logical device. What DNAC is, how we deploy DNAC. You've got DNAC up and running, and zero-touch provisioning, and what we're trying to do with zero-touch provisioning. Essentially, deploy a device without touching it. Well, you have to touch it, you have to rack it, you know what I mean. So the lab, this is the lab we have to do this testing with. What I have is I have a DNAC appliance over here on 1337 and I've got a stack of switches. I think there's a stack of 5 in there. It's not really important because I don't think I'm going to do much on the CLI today. I just trust that I've validated this stuff. And me, you know, I'm a trained monkey, so that's how I feel sometimes dealing with this stuff. It's just trying to figure it out for you fine folk on the interwebs. So let's go and console it and hope you like that little animation. That took me far too long to get working. So what is the problem? So in reality we have this non-sequential top-down order of switches where switch 1 we can see there is the third one, switch 2 is the top, and so on and so forth. If you have your local on-site admin or anyone that's doing the cabling, you ask them to plug the device into port 4 on switch 3, for example. Excuse the numbering, it's not logical. Well, where is switch 3? They first have to figure out that this is switch 3 to figure out to plug into port 4 over here. Whereas if it was 1, 2, 3, if this was always switch 3, then they know that this is the correct port here, port 4. And then yeah, so this is a good feature actually. In what 17.4, there's this feature coming out called fast code upgrade. So typically when you deploy stacks, you'd have your uplinks at the end. So you'd have a network module either end of the stack, the top and the bottom, and then be your uplinks to your next layer up, be that distributional core. And the guidance was to deploy the master and the backup as middle tier switches, and then the edges as members, due to faster convergence of the routing protocols. You can read about this if you're interested. To ping me in the comments, and I'll send you where the information is that you can read up on. But in 17.4, there's this feature called fast code upgrade, and for that to work, the master should have the uplinks on, so that's either this switch or this switch, assuming they're the ones connected to the upstream layer. I can't remember the exact times. I think it's something like 15 or maybe 30 seconds I saw for outage when doing this upgrade. And then it does the tops, it does the master first, and then each switch sequentially. But I ping in the comments if you're interested. We can talk about that, and I can send you where the link to that information is. So the desired outcome, of course, is this: bomb 1, 2, 3, 4, top down. It's repeatable, it's known, it's predictable. We know switch 4 is the fourth one, switch 1 is the top one, and switch N up to 8. So how do we resolve this if we're out of order? Well, on install, you just power it up one by one. Switch 1, wait 120 seconds. Switch 2, switch 3, and switch 4, and then you move on. 1, 2, 3, 4. Brilliant. That would be perfect if that worked every time, right? But what if you ordered 2 separate orders and they're on different versions of code? Then you get a version mismatch, don't you? So if you boot up switch 1 first, then he's going to be 16.6.1, and you end up with this version mismatch. So then you have to do some manual interventions and do a code upgrade to make them have code parity. So what can we do here? Well, you can upgrade each switch, reboot them in order, and away you go. But we don't want to do that. You know, that is just painful. There is this software auto upgrade enable command, so we could type that in to the master switch, or if there's 3 switches already in the stack on the stack of switches, and that basically says that if a new switch boots up and it's incompatible with the switch stack, then it will try and upgrade to the code that's running on the stack, as opposed to going into version mismatch mode. I don't know. This is not enabled by default. This feature. I think it would make sense to. I don't know why. Maybe I should do some digging there and report back to you. But it's not zero touch provisioning. Correct. It is not zero touch provisioning. It requires intervention to put that command on. Bosh. You can do it like this, right? So put it on a USB. You could put on a USB and you do USB boot. And what I mean put it on a USB, well, if you save this file onto the USB in a file name router-conf router.cfg, Cisco router.cfg, when the device boots, it looks for the presence of, it tries to do plug and play. It tries to do lots of things. One of them is it tries, do I have a USB device inserted into my USB port? If I do I see one of these files present? And if it is, what's the configuration on there? Software auto upgrade enabled. Done. And then it will deploy that configuration to the switch. Note that this will not interrupt the plug and play process. So you can do this and you can still continue on with your normal plug and play. So we're kind of still in the realms of zero touch provisioning. We just need to take this little USB key with us. How else could we resolve this? So we could boot one switch. So that now we've got our uplink connected to our, say, our intermediate layer. Presume it's SDA or our distribution, whatever the current flavor of terminology that's being passed down from above to us. But we've got, so this one's on 16.6.1. We boot him up, and then we run LAN automation, right? That's assuming you're running SDA. Then power them up. We can discover and provision that single node. Again, LAN automation, or just provision it via just a normal CLI template with DNAC. I'm making an assumption here we're using DNAC. And part of that, we can push down this software auto upgrade enable command. So the active provisioning, we have a custom CLI template. Done. Then what do we do? Then we just simply go and power each switch up in turn. And they will, assuming they're on a different version of code, they will then go and download that version of code to the device. And that solves your version mismatch issue. And it also puts the stacks in the right order, provided you've booted them up in a top-down approach. And then cable up that second link, and you can then rerun LAN automation. So how that would work is we move the seed device over to this next switch. You run another LAN automation job, selecting this fella as your top, as your primary, and then this guy is the secondary node. Run LAN automation, and it will automate that as a layer 3 link. Absolutely brilliant. So we can get around the SDA LAN automation, and of course, if it's not SDA, then we've got a provisioning template, so you can just push out another CLI template with the respective configuration for that device. And then push down the priorities to the stack. So how would this look? So here we have a template that basically has a variable of stack count, and then that is a user input, which is, if it's the number of switches 2, then we set the relevant stacking for 2. If it's 3, we do the right configuration for 4, 3 and 4 and 5 when we've set the respective priorities. That's the subsequent reloads of the stack. The priorities would be retained. Then we choose, when we're provisioning, we ask the user to give us that information, and we can tie this to set variables. We're basically saying it's an integer. They can choose just one. and then we say the range, and then we can define here what is the values they can enter from a drop-down list. So the drop-down list, the items on the left, like for example, I could type in a new value here, Sam, and then what the value that will be transposed to in the template, the number 6. Then if we save this, and then we can run a simulation test to see what that would look like. So from our test, we edit this current one and we change this down to a value of, say, 2, and run this. We can see the template is transposed to do a configuration for priority for 2 switches. Now we could change this to, say, 5, and it sets the relevant priorities for a node of 5 switches, or user-friendly attribute Sam. And as we saw, the Sam transposes to the number 5, or 6, sorry, so then we've got the priority for 6 different switches, as we can see over here. If we take a look at the Sam attribute, it's got the actual value will be 6 that's associated with that. So it's quite useful. We can really lock down what users can and can't do. Okay, so what else? What happens if this bombs out during the setup, right? So we've got an install engineer. He wants to get in, he wants to get out, he wants to go on with his day. He doesn't really care so much about your stacking priorities. So this is the guy you choose to do the job. You know, we all know one of these guys. Look at that mess. We've all been there. Anyway, so he basically just boots up switches 1, 2, 3, 4 in the wrong order. That's not so bad. What's the worst case we could have here? Well, one of these switches is in a version mismatch mode. So this guy here is in a version mismatch mode, as well as the stack being out of order. You know, this is a double whack. And we can see that show switch. We can see that it says version mismatch. So how would we get around this? Let's move this thing out of the way. Fix here, so we can discover and provision the working stack, so all the switches in the stack as they are, and then bounce the version mismatch switch there. So essentially, we're pushing down this software auto upgrade enabled again, and then reload slot 3. That will actually say reload slot 3. It's actually 4 on the diagram, but it's 3 here on my actual lab, which is this guy here. And that'll reload that one. And on reload, guess what? It's going to join the stack, and it will see software auto upgrade is enabled, and it will download that version of code, which is good. And then we can go back and do, as we did in the previous slide, if this was one with uplinks on, then we can re-push down the relevant config for that, or we can rerun LAN automation for that port to push down the respective config. So we power him off, clears the version mismatch, power him back on, and we are happy. Yeah, as I just said, if it's a member-only switch, no uplinks, you're good. Just joins the stack. It's DNAC again, assuming you're running DNAC, then we just rerun discovery, not discovery, we just repoll that switch. So just resync it, and then we'll discover that new switch. If it's got an uplink on, then yeah, LAN automation as we described previously. Going on then, so in reality, stack ordering, so we just get an out of order stack, right? We've got 5 switches here, 1, 2, 3, 4, 5. You know, no version mismatch, assuming we fix that, or you've just fixed that, and now we're moving into this step, but we've got out of order stacks. How do we deal with this? You know, how do we fix it? Well, get your install engineer to glean those serials as you deploy the nodes top to bottom. So serial 1, 2, 3, 4, and 5. Sure, you can get the serials yourself if you just show platform or show inventory on the box, but you know, switch 1 will show you is this switch here. It won't show you the top one in the stack, and that's what you want to know, is the top down to the bottom, right? Top down, so we can reorder it appropriately. And you can see this in DNAC. If you go onto DNAC as well, you can see how this correlates. So switch 1 will be the first serial, switch 2 is the second, 3, 4, and 5. That doesn't give us any clue as the actual physical layout of the land. So grab those serials as you deploy it. You're going to need them to do this next step. And you can validate this on the CLI, right? So show platform, and then we can see here switch 1, switch 2, switch 3, switch 4, switch 5, which correlate to switch 1, 2, 3, 4, 5. Happy with that. So how do we solve this situation? We're in this pickle. We need to get out of this pickle. So a simple one-time config, we can just push down. You know, we can do this manually. We can do this with a CLI template. It's just an interactive command. So switch 1, renumber, 3, switch 2, renumber 1. So we know that switch 1 should be 3, switch 2 should be 1, 4 should be 3 should be 2, sorry, 4 should be 4, and 5 should be 4 should be 4 and 5 should be 5. Yeah, so we just run that command, write, run, and reload, and then the switch will bounce back as normally. So you just have to correlate the serials to the switches and their respective positions that they need to be. A little bit manual. Is it zero touch provisioning? It's maybe not. One could argue one's case either way. You could use an advanced CLI template. This is if you want to geek out and do this a bit more. This works. It's really good. So basically, we turn on shell processing, which allows us to create variables on the device to use. So in this case, I'm going to create a variable switch 1, switch 2, switch 3, switch 4, and switch 5 based off of the output of these commands. So switch 1 serial. So the user is going to be asked when you provision, what is switch 1 serial? Which is going to be this serial here. So, and we know this because we've already gleaned it here. This top serial number, we've gleaned it when we've deployed the device. So we type that in. And then this script or this command is going to take the output of the show platform. It's going to grep for the serial number, and it's going to cut the second and third character. There's actually a character here which we can't see, but it's going to take 1 and the next character, which could be 1, 2, 3, 4, 5, 6, 7, 8. It could be number 10. I think you can name them up to switch 15. So we've allowed for that. Then that number is going to become that variable. So if you echo $switch 1, it will echo back the number 1. Then it's going to be pumped into this command here. So we've got mode enable, because this renumbering is an enable level command. You can't use the do, do show IP and brief, that doesn't work. And it's an interactive command as well. So we're wrapping this up in the Velocity template language with these 2 different sub modes. And the interactive, so that's running it as enable command. This is running it as interactive, which when we run this command, we're expecting a question back. A yes or no should be the expected question, and here is our response. So what this does is it types in switch 1, because it's pulled this information from here using this variable, renumber to 3. 2 to 1, 3 to 2, so on and so forth. Then as we go down, we need this to reload to take effect. If you simply do a reload at the end of this template, your provisioning will fail. It will report that it's failed. And why will it do that? Because at the end of the provisioning process, the device and DNAC then go through another sync process, and basically they report on whether they were successful or not. That will take place after the configuration has been pushed down to the device. It's basically checking that it's been successful. So if you instantly reload the box, then that will fail, and you'll end up in this loop. So you can either manually reload it, or you can just write a little event manager script, AEM script, that saves the config, waits for 30 seconds, then does a reload. This might not be enough time depending on your switches. You can make it a minute. Just play around and test it, and then run that. So it needs this event none, so that it can be fired. So this is quite cool, and then we can make this. You can go one step further and make this. I say foolproof. You can make it easier for your operators. So what we do is this switch 1 serial is part of our CLI template here. So that, you're asked to input the serial numbers. Who type in this user error, prone for user error there. So what we can do is we can bind this to the inventory, to the device, and to the serial number. So when the device is within the DNAC inventory, we know things about it, and we do know what the serial numbers are. And then when you're asked to select the serial number, you've simply presented with all 5, in this case it's 5 switches, 5 serial numbers of that device, and you can just delete the ones you do not want. Unfortunately, you cannot make this a drop-down list. If you tried to change this to a single select item from the serial number, if you actually look in the DNAC inventory, this is saved as one logical entry, not multiple entries that you can choose one from. So this is the best we can do, but I would argue this is pretty good. So then we take that, we choose the serial numbers, and they are then used as the variables in here to reorder your stacks. I think this is pretty cool. And then I 17. I tested this in 17.3. I think I tested it in 16.12 as well. But I've been using these grepping of variables for a while now. And one thing to pay close attention to, these little backtick things. There's two types, especially on my Mac. There's the one in the lower left above the control keyword, which is the one I'm using here, and there's the one over on the right near the carriage return. Don't use that one. That one just gives you problems. So moving on. Once we've done that, then we're kind of good. What else? Oh yeah, there's more options. Of course, there's more. You could use a Python API to look up the switch and then do a push of that same configuration. Write a function to do an API call to DNAC, get a token, look up the stacks, and then write the same CLI and push it, and then access the node and something like some SSH. I can't remember the import we use for SSH, Paramiko or pexpect. But then you're deviating away from doing everything with DNAC to just adding more tools to make it more complex. Console on, plug in your console. The engineer's there, right? He's there already, fitting the switches. I'm guessing you're sending an engineer and you're not sending like your line manager or somebody who's not very technically apt. At least to have a console cable. They would always have a console cable, right? Why don't this console on, set the switch order and reload? Yeah, sure, it's not zero-touch provisioning, but geez, you're saving yourself a lot of headaches here. But of course, there's ways to fix this, which we've just talked about. This command's cool. So in 16.12, this was introduced. Instead of having to wipe the box, so when you console in and you interrupt the start process, the auto configuration process, it stops plug and play. Once you go and you do the manual configuration of the stacks, you can type in this command, pmpa service reset, and it will wipe the box, reload it, and then it will restart plug and play. Bearing in mind that running this won't wipe the configured order of the stacks. And so that's it, really. That's it. In summary, we just deploy via console, wipe and reload. That's always the preferred option. Use the software upgrade, software auto upgrade enable if you've got version mismatch boxes, and then you can either, if they're member only with no uplinks, then they join. Happy days. If not, then you can run sort of provisioning or rerun LAN automation for that newly joined switch that needs a layer 3 or other type of uplink configuration applied. Boot the stacks in order. If they're all shipped to the same order, same version of code, then boot them in order, top down, then you should be good to go. Of course, verifying that. It says boot the stack in order again. I guess, I don't know, I wasn't trying to make that point important. But the other things we can do is we can use those manual methods. My favorite is to use the template DNAC with the variables, and then you can just prompt the user for the serial number that you want to be switch 1, 2, 3, 4, 5. Although it becomes an extra step, and then it's still prone to error. Possibly if you've got if the serial number's in the wrong order given to you, or something goes wrong with the pushing of the template. So I always go for option 1. Deploy it first, stack via the console, wipe it, and then move on. It's a one-time thing. Really, because then after you've deployed your stack in the right order, you can then push down a template which sets the priority, so you should get that parity between reloads.